day, everyone, and welcome to the 19th edition of the group exhibit, Hydrogen and Fuel Cell, here at the HANNOVER MESSE 2013. I invite you to take a seat. We have our public forum discussions today that will run all the way to 5 o'clock, so please have a seat, join us for great discussions. We're going to start the day with Hydrogenics, discussing accelerating the shift to simplicity for zero-emission mobility OEM. Please help me welcome the Business Sales Manager of Europe, Martin Troge. It's a pleasure to have you with us.
Thank you. Thank you for having me.
Well, why don't we start by getting right in the main topic of it. Could you describe to us what are the main challenges an OEM usually faces when they want to use fuel cell in their application?
Well, if they want to use fuel cells in their application, the main problem is that you buy a fuel cell, but you need a lot of components around it, balance of plant, a lot of engineering, and there is also very often a lot of try and error linked to it, because if you don't have testing infrastructure, it's very difficult to create a proper working balance of plant around the fuel cell.
So you're basically saying that a fuel cell, a stack, is complicated. As soon as you change a criteria, let's say you change the pressure of the gas going in, everything around it has to change. So if an OEM wants to use a fuel cell, they could lose a lot of time and efforts.
They certainly do.
They usually do.
Yeah.
But Hydrogenic has come up with a solution for that, and they have spent over 10 years developing a system that eliminate most of the but overcome those problems. Could you give us some of the main characteristics of the HiPEM product you're offering?
Well, first of all, Hydrogenics has all that testing infrastructure. So the idea was today, why not use it and develop all the balance of plant around the stake already and give the customer a working plug-and-play product at hand. So the HiPM products have their own air supply, they have their own controllers, valves, electronics. So you basically connect hydrogen and a cooling system to it, and you can basically start operating it.
You have one of those HiPEM units on display at your booth.
Yes, we do, yeah.
So I definitely invite you to go and visit their booth, which is just behind us at C59. And those HiPEM units, you also mentioned to me that there's a wide range of flexibility in the range. So depending on the OEM that wants to use it, there's different sizes. Can you give us a bit more information on this topic?
Well, today our product ranges from 2.5 kilowatts up to 180 kilowatts in different stages. Basically for mobile heavy-duty applications, we start with the 30 kilowatt block, which we call a Lego block. And since the operation of all these modules is the same, you can scale them up to 60, 90, 120, up to basically, in principle, whatever size you need. You could even build megawatt blocks out of it.
So you really took away the problem of sizing a special stack for a certain application. You can parallel them based on the size that the OEM needs.
We still do, well, we have so-called standard products that customers can at first take a look at and choose whether those are suitable for their application, but at the same time Hydrogenics does also special designs for special applications like aviation, military applications, etc.
One other thing you had mentioned to me earlier was also the fact that Hydrogenic worked at using reliable standard products. What would that be in the balance of plant of the HiPEMs?
You mean reliable? Well, the reliability is one of the most important things, and if there is a problem with such a system, it's almost never the stack. It's always the balance of plant. It's humidification, it's loose wires, it's the control. and different other aspects that often cause trouble, and they have to be smoothened. And since we do have all the testing infrastructure and the experience, we smoothen that for our customers. We pre-choose all the balance of plant around the stack. We configure it. We put it together so that the customer can start working with them right away.
So it becomes a plug-and-play unit.
It is a plug-and-play.
And so knowing it's a plug-and-play, what do I need to plug to make it play?
First, you need the ability to plug and the will to play. But basically, you connect, as I said, you connect cooling water and hydrogen. You need a usual 12-volt battery, or just like a car battery to start it. And then you need a CAN command, like CAN bus communication to the module, and to simply tell it, start, stop, give me more, give me less, follow this curve, follow that curve, and it'll do it.
On the CAN bus communication system, do you get more information that could be displayed inside the OEM system?
Yes. You can not only give it commands, it also gives information out that you can process in, in displays, or program something around it that you can see. Yeah.
And on the hydrogen side, how much pressure and what quality of hydrogen do I need?
Well, we need at least 4 bars pressure for the system, because we don't need any inertization anymore. So we don't need any nitrogen gas to neutralize the stack, and therefore we need at least 4 bars pressure. Better is 5, but 4 bars is just a little bit more than that we need.
And it would be hydrogen at 99.99%.
Exactly, yeah.
Is what you had mentioned to me. And also, what I'd like to know is which product do you mostly, or which end product do you mostly target as a company, as Hydrogenic? Where do you see the high PM module?
Well, actually, there is 2 main focuses. One is backup power, UPS power, and the other is mobility. And there we focus on heavy-duty mobility at the moment. So everything which is a forklift, a truck, a bus, which is like a bus per se, an expensive product, like special street cleaners, like buses, hybrid buses. This is what we focus on at the moment.
Well, you've just mentioned communications. I believe Hydrogenic is well established already in the telecom. Do you see this market continue to grow, or we've kind of reached the main high already?
Not so much in Germany. There are other regions in Europe that are a little bit more promising, but the most promising part in the world is Asia at the moment for telecom.
And why is that?
Well, we can probably explain it vice versa. Why isn't that here? Here we have a very good cell coverage of the telecom network. So if one cell fails, you wouldn't even recognize it. So that you wouldn't lose your call. In other countries, in Asia, it's probably, or in India, let's say, you need every cell, and you would recognize, you would lose your call if one of them fails. So you need an emergency power there, and that's a possible application with all the problems that you have from the logistics there. Get hydrogen or get methanol there, but at the moment you need to get diesel there as well if you have a diesel genset there. So I've heard that they're gone after a few weeks because people discover that they can use diesel gensets for something else as well.
And then, so Hydrogenic has, from our discussion earlier, you've been saying that has really focused on making his high PM power module as easy as possible for the end user, for the OEM, so they don't need the experience, they don't need to go through all the roadblocks to learn the technology, because it is complex. We can't hide it, it is.
Yeah.
But one big aspect that I liked about when we met before this interview is the fact that you've also made the pricing clear, and people can tell, you can tell them how much it costs, and then they can plan accordingly. Could you
Exactly.
share that information with with the people here in the audience?
Well, the module that is on the booth is a 33 kilowatt module, and the price is 2,000 euros per kilowatt, while 100 units would be even below 1,000.
So basically, you have a standard price for a
Yes,
single unit.
I do have a standard price list. I can show it to everybody, but I don't. But if somebody wants to know a price from me, I can look it up in the price list and name the price right away for any kind of product.
But the
that we
price
have.
kind of comes down really quickly as soon as you get in the 100 units or so,
Yes.
which means that Hydrogenic has the manufacturing capabilities to support large volume demand.
Well, this is a tricky part. We use graphite bipolar plates still. We don't use metal bipolar plates because it's very expensive to build a tool to make the metal bipolar plates. So that would be a mass production product that we would use for stacks. We're ready to do so, but for cost reason and for demand reason, we still use the graphite bipolar plates. So if it comes into volume, you're talking a different story. We're talking about tooling, we're talking about automation, we're talking about many kinds of things. We're talking about the products getting even smaller then because the metal bipolar plates are much thinner. Today we can build, I think, something like 4,500 or so
A year?
a year. Yeah.
And where is your manufacturing facility located?
We have two facilities depending on the business. So we have two business lines. One is electrolysis and everything linked to it, and the other is fuel cells and everything which is linked to it. And so the fuel cell products are made in Mississauga, Canada, and the electrolyzers are built in our facility in Belgium, while our German facility is specialized in engineering. So there might still be customers who say, listen, I have a truck, but I don't want to do any integration, not even the battery, not the electric engine, nothing. So he can give us the electric truck and we do it for him. So we do all the engineering around it.
Here in Germany.
Yeah.
By the way, anybody in the audience is welcome to ask questions. It is an open public forum. So if you have a question, please raise your hand. I'll come and see you with a microphone, and then you can ask directly to Martin Trugger. Will also be available at his booth after the interview, which is located just behind us at C59. But to continue the discussion on your system, the high PM, what do you think Hydrogenic foresee in the next 5 years? What is your next focus? Now that you've made a product nice and easy for the OEM to integrate, it's off the shelf, you pick it up, you just plug and play like you said earlier. What is the next focus? What do you see 5 years down the road for Hydrogenic?
Well, I would be a very rich man if I knew that and it would become true in 5 years. But let's assume that within the next 5 years, I hope, and I cross fingers, the car industry will ramp up their production or start their mass production like Daimler announced it, because that will again drop material price and material cost and make fuel cells per se cheaper and more affordable for customers.
So you would say that the announcement from Daimler is a really good news for the industry?
I hope so. I mean, there have been many announcements in the past 10 years, but one of them must be true from different players, of course. And there are other OEMs like as Daimler. Like there's Toyota, there is Volkswagen, there is BMW, whoever, and I hope they will bring out their cars very soon, so that over the volume prices of the materials, the cost goes down again.
So you think that the major changes when the car manufacturer go ahead with this production will be cost reduction overall on all products, and like the bipolar plates and the stack itself, even your product, for instance, because you can acquire your material at less money.
I mean, we have different balance of plant, of course, but the materials that go into a fuel cell are the same basically. One customer needs another recipe for its membranes as the other. There are different details into it, but basically the price will drop, and we hope that it will benefit the industry.
Well, I will thank you very much, Mr. Trugger, for your time here.
We're ready already, okay.
Again, Sorry, we're on a time clock. We try to
Okay.
get it over the 20 minutes. There'll be another interview following, so stay with us for residential fuel cells, stepping from field test to market with IBZ. Thank you so much, Mr. Troger, for your time with us.
Thank you.
Thank you.